Have you ever heard of a potential holy grail for energy? You know, a power source that's cleaner, safer, and way more powerful than anything we have today? Well, for decades, that's what they've called thorium. And the story of how it just went from science fiction to reality, well, it's pretty incredible.
And it all kicks off with this quote. I mean, wow, it really sets the stage. Because while thorium has been a dream for a long time, one country just woke it up. And they did it using another country's forgotten blueprints. This is a fascinating story of abandoned genius and what happens when someone else picks it up and runs with it.
So what exactly is this game changer? Well, something just happened. Pretty quietly, far from the spotlight, but its ripple effects could be absolutely enormous.
That's right. Picture this. Out in the middle of the Gobi Desert, China has just fired up a revolutionary new kind of nuclear reactor. But here's the kicker. The entire thing is based on declassified American research from the 1960s. Research that was just abandoned, left on a shelf for over 50 years. This isn't just a cool science experiment, it's a massive geopolitical development.
Okay, so why all the hype? What is it about this thorium stuff that has so many smart people throwing around terms like Holy Grail? Let's break down what the promise of thorium really is.
The first thing you need to understand is efficiency. And just look at this chart. The difference isn't small, it's staggering. A thorium reactor can be up to 200 times more energy efficient than a traditional uranium reactor. We're not talking about an incremental improvement here, this is a whole different ballgame.
To really put that into perspective, here's a great analogy. Imagine you have a battery powered by uranium and it lasts for 1 day. Okay, not bad. Well, a thorium battery of the exact same size would power you for 6.5 months. That is the kind of leap we are talking about. It's just incredible.
And of course, there's the big question with any nuclear technology, what about the waste? Well, this is another huge selling point. The waste from a thorium reactor becomes safe in about 300 years. Now, that's still a long time for sure, but compare it to traditional uranium waste, which stays dangerously radioactive for over 10,000 years. It's a night and day difference in long-term safety. So let's just recap the big 4 advantages here. 1, thorium is way more abundant on Earth than uranium. 2, the reactor design is inherently meltdown-proof. 3, the waste problem is massively reduced. And 4, as we just saw, the energy output is off the charts. Sounds pretty good, right? But how does it actually work? Well, the secret sauce is in the reactor itself. It's called a molten salt reactor, or MSR. And instead of the solid fuel rods you might picture from old nuclear plants, this design uses a liquid fuel. That liquid allows it to run at normal atmospheric pressure, which is a huge safety win. And get this for a safety feature, if anything goes wrong, a little frozen plug at the bottom melts and the liquid fuel just drains down into a safe holding tank. No pressure, no explosions. Now the science might sound a little complex, but it's actually a really elegant process. You start with natural thorium. You hit it with neutrons, it goes through a couple of quick changes, and then it turns into a special type of uranium that you can use as fuel. The reason the liquid reactor is so important is that it lets this whole cycle happen continuously, something that's just not possible with solid fuel rods. So all of this raises a pretty obvious question, right? If this technology is so amazing, why are we only hearing about it now? Why on earth would the country that invented it just abandon the dream? The answer is a really fascinating piece of forgotten history.
I mean, this timeline says it all. The US successfully ran a thorium reactor back in the 60s, and then they just pulled the plug. The research sat on a shelf collecting dust for decades. Then, in 2011, China decides to pick it up. And in just over a decade, they've got a working reactor. That gap is the real story here.
And the man at the center of that original vision was Alvin Weinberg. He was the director of America's top nuclear lab, and he saw thorium as a way to literally change the world, to provide clean, abundant energy that could make deserts bloom by desalinating ocean water. He had a huge vision for it.
Weinberg himself never really understood why his project was killed. He famously said there were no technical reasons for it not to succeed. The science worked, the experiment was a success, so what happened?
The answer in a single word is politics. Remember, this was the height of the Cold War, and the #1 priority wasn't cheap, clean energy for civilians, it was the nuclear arms race. The military needed reactors that were really good at making plutonium for bombs. Thorium reactors? They're terrible at that. And so the path that led to better weapons won out, and Weinberg's dream of clean power was shelved.
Okay, So let's fast forward to today. China has revived the dream. But it is so important that we separate the huge potential from the current reality on the ground. What are the actual hurdles that are still standing in the way?
There are three really big ones. First, the economics. The fuel itself might be cheap, but building the complex chemical plants to process it has always been a major cost barrier. Second, material science. That super hot, super corrosive molten salt is an absolute nightmare for metal parts. It just eats them away. And third, and this is a big one, scale. We have to be crystal clear. China's new reactor is a tiny test unit, a proof of concept. It's not powering a city.
But to be fair, real progress is being made. On that materials problem, for example, Chinese scientists have actually developed a brand new custom metal alloy specifically designed to survive inside that corrosive salt. It's a huge materials science breakthrough, and it's a big step forward.
And let's just put that scale into perspective one more time. The Chinese reactor produces 2 megawatts of thermal power. That is a huge scientific achievement, don't get me wrong. But the little research reactor on the MIT campus, it's actually 3 times larger. So we are still in the very, very early innings here.
So, where does all this go? China has obviously jumped out to a pretty big lead, but are other countries getting into the race for what could be the future of energy?
The race is definitely starting to heat up. China is already planning a much bigger reactor by 2030. You got a private company in Denmark that's testing its own design. India is a huge one to watch because they have the world's largest thorium reserves. And back in the US, a bunch of startups are trying to revive that old American dream. But for now, a lot of their work is still on paper.
And this final quote from the head of China's project, I think it puts everything in perspective. This isn't about chasing quick profits. This kind of world-changing technology requires decades of focus, of public investment, and just unwavering dedication. It is the definition of a long game.
Which, of course, leaves us with the ultimate question. After spending decades as a sort of technological myth, thorium power is finally a reality. But is this the start of a clean energy revolution that's going to change our world? Or will all those technical and economic hurdles prove that it's just a really fascinating but ultimately expensive distraction? For now, the entire world is watching the Gobi Desert.